the screen sharing and recording. Today I'll try to finish this multiple function, but I'm not sure whether I'll be able to do so. Anyway, so I'm going to consider three topics today, or at least try to cover the three topics. First is the nature of the cost function. Second is I'll return to our old buggy bear, the constant elasticity of substitution function, production function. And third is, if possible, I'll try to discuss some issues relating to the inferior goods, Giffen's goods substitution effect. Okay. Now the first topic is the cubic cost function. See, if you look at the right-hand side, uh, the cost function that we draw, actually there's a slight mistake over here. I've drawn it starting from the origin, but as you know, that the cost function comprises of fixed cost and variable cost. And unless fixed cost is 0, the cost function will not start from the origin. So the positive intercept indicates the fixed cost. Okay. So the fixed cost is, you can say it can be divided into two parts. This part is concave and this part is convex. So this is the point of inflection. And the corresponding marginal cost curve is U-shaped. Now the question is that we want to answer today is that what type of cost function will generate a function like this and a marginal cost function like this. Okay. Now a cubic cost function, this type of function can be generated by a cubic cost function. C equal to a to the power of a q cube plus b q square plus c q plus d. So the first condition that marginal cost, if you look at this type of marginal cost, is inverse U-shaped, and marginal cost has to be positive. Now, if you want to ensure that marginal cost is positive, the easiest way is to say that the minimum average cost, the point where average cost is minimum, is positive. So this is in the first quadrant. This minimum point is in the first quadrant. Okay. So the marginal cost is equal to dc by dq. We take the differential. We get 3aq square plus 2bq plus c. Now this is a quadratic function implying that the MC function is a parabola. Now can this, when we are talking about parabolas, the function can be like this or it can be like this. Now if you have an inverse U-shaped function, okay, at some point the marginal cost function will become negative. And we know that this is not possible. Marginal cost negative means that you are increasing production, but your cost is decreasing. This is simply not possible. But if you have a function like this, U-shaped, then it is possible that, in that case, the marginal cost function will be maybe positive. See, in this case, it is still U-shaped, but it is not positive in this range. So first is it has to be U-shaped, and secondly, the minimum point has to be positive. MC min has to be positive. Okay. So let us find out MC min. So what we want to do is to minimize the marginal cost function. So we minimize this. We take the differential derivative and set this equal to 0. 6aq plus 2b equal to 0. And we solve for q. And we get q is equal to minus b by 3a. Okay. Achha, by the way, before I forget, if the parabola is U-shaped, then A has to be positive. Okay. So this is the first condition. So we want to evaluate what will be the restrictions on A, B, C, and D. So if the marginal cost function is U-shaped, then A has to be positive. Okay. Now we want to derive the restrictions on B, C, and D. Now, Q cannot be negative. Negative output doesn't exist. So that means A is positive. This is minus. So that means B must be negative. So we have found out A is positive. This is negative. Okay. Okay. Second is we take the second derivative. This is 6A. A is positive. So that means the optimum, the extreme point that we have found over here using this equation is really a minimum and not either a point of inflection or a maximum point. Is it clear, everyone? Any questions? Okay. Now, let us substitute the value of Q star that we have obtained over here. Q is minus B by 3A. Let us substitute this into the MC mean function. So we substitute in place of Q, and if we simplify, we are going to get this expression. Now, remember that what we have said is marginal cost, the minimum marginal cost cannot be negative. This has to be positive. So 3AC minus B square by 3A is positive. Now 3A is positive, A is positive. We have already shown. So this condition, the numerator must also be positive. That is 3AC must be greater than B square. Further, see, B squared is positive, A is positive. So what is the sign of C? C also has to be positive.
Positive.
Yeah. Okay, so we have shown the conditions on these three constants. Plus, we have said that B square should be less than 3AC. There's a further constraint. The final constraint, what is D?
Hello.
Now, as
Sir,
yes,
could you show the previous page? Yes, sir. Yes, sir.
yeah. When you finish, let me know.
Yes, sir.
Okay. So we know what is the sign of A, B, and C. Now, what is D? Now, the interpretation of D is it is simply the fixed cost. Right? When Q is equal to 0, C is equal to D, the total cost is equal to D, which means that D is the fixed cost. So if fixed cost is positive, which is a quite reasonable assumption, then D will be also positive. In the long run, there is no fixed cost. So in that case, D will be equal to 0. So in general, we can say D is, in the short run, D is positive. In the long run, D is 0. Or if you want to generalize, D is greater than equal to 0. So that means these are the three conditions on the short run cost function. A, C, and D must be positive, B should be negative, and further, B square should be less than 3AC. Okay. Now, I want to introduce another concept which you will not require now. It's mainly required in the next semester when MD will cover optimization. This is the Jacobian determinant. Consider two functions. I've written a function, but it should be two functions. y1 equal to f of x1 and x2, and y2 is a function of x1 and x2. Okay. So how many first order partial derivatives will there be? Y1 can be differentiated in terms of x1 and x2, and y2 can be differentiated in terms of x1 and x2, right? So there are 4 partial order derivatives. If I write this like this over here, okay, so I take the first function and I write down all the partial derivatives. Then I take the second function and I write the first order partial derivatives. Then this and I take the determinant. This is called Jacobian determinant. By the way, I hope you know what is determinant. সবাই determinant কি জানো তো?
হ্যাঁ স্যার।
Yes, sir.
Yes, sir.
আচ্ছা. This can be generalized as y equal to, if I've not 2 equations, but let us say I've got n equations, and each of the n equations are a function of x1 to xn. Okay, so y1 can be differentiated with respect to x1, x2 up to xn. So this is what I've written in the first row. The second function is y2. That is also a function of x1 to xn. So I've written it over here. Del y2 as a derivative of x1. Sorry, this should have been x2 up to xn, and so on like this up to the last row. So this is a nth order Jacobian determinant. So if I have, let us say, 4 equations and 4 variables, I'm going to get a 4 into 4 order Jacobian determinant. So we are talking about a square determinant. Okay, if the determinants are square. Now suppose your
Sir, can you
Yes.
show the previous slide once more? Done, sir.
Okay. Now suppose you have 2 functions, y1 equal to 2x1 plus 3x2, and y2 is equal to a little bit more complicated equation. Find out the Jacobian determinant. Write down the expression and find out the value of the determinant.
Sir, 0.
Yes. So the Jacobian form is like this. And if you take the determinant, it becomes equal to 0. Okay. Now look at y1 and y2. If you take the whole square of y1, what will you get?
Say y2.
Yeah. So in this case, we see that okay. So this is a case of a what we call dependence. Okay, one function can be written in terms of expressed as a function of the of some other function in this. So let us say if I have suppose I have three equations and let us say that y3 can be defined as some function of f1. Okay, this is called dependence. And in this case, we have a nonlinear function. But if we have a linear function, like for instance, let me give an example 2x1 plus 3x2. Let us suppose this is what y1, this is a linear function. And let us say y2 is equal to 4y1. So in that case, it will be 8x1 plus 12x2. Okay. So this is a linear transformation. Y2 is a linear transformation of x1. So we call this a linear dependence. Another type of dependence is like this. Let's suppose y3 can be written as like this. So in such cases, this is again a case of linear dependence. Or
Sir,
if I have, huh,
sir,
yes,
sir, I couldn't understand this part. I mean, the linear dependence part. Can you tell once more, sir?
okay, so suppose we have an equation like this. Suppose we have an equation system like this. Now, what is the relation between y2 and y1?
Y equal to 3y1.
This is equal to 3y1. Okay. Now consider this equation. If you look at this, we can write y3 as, right?
Yes, sir.
Acha. So if you have a set of equations, okay, obviously, I mean, we are talking about, since we are talking about linear dependence, we have a set of linear equations and one of these equations can be written as a combination of the other equations. Then we call it linear dependence. Okay, so the general form is, if I take the 3 equation case, lambda y1 plus lambda 2 y2. What is the value of lambda 1 over here?
1.
It is 1 and lambda 2 is 3.
Yes, sir.
Okay. Let us take a 4 case. We add an equation over here. To this equation system. Okay. So here we can say that y1 is equal to one into y1, 3 into y2 plus 0 into y4. Okay.
Yes, sir.
What I'm basically saying is I don't have to include all the equations. Okay, if it is a combination of some of these equations, that will do. Here I've got 4 equations. Y3 is a combination of the first and second equation, not the last equation. Okay. So linear dependence just implies that I have one equation. This is a combination of some of the equations, some or all of the equations. Is it clear?
So,
Yes, sir.
so, so that
Yes.
means, so while finding y3, so we can just use the first equation, right? Like multiply the first equation by 5 and the second equation by 0.
No, could you repeat what you said?
So like so if y3, so you said like we can just multiply it by 0. So as in the case 4, so y equals to 4. So like that only, so if you find like y3 equals to 5 into y1 plus 0 y2, so we can write it like that also, right?
Yeah. We can also write it like this. So basically what you're saying is something like this. Y1, let us say y1 is equal to 2x1, 3x2. Let us. You mean something like this?
Yes, sir.
Yeah. Yeah, this is possible. So you have to have one equation which is a combination of at least or transformation of at least another equation or a set of equations. Here it is one equation, here it is a set of equations, 1 and 2. Okay, so in general what we write is, let us say n, we can write it in this form. When some lambdas can be 0. Okay, maybe lambda 2, lambda 5, lambda 7 is 0. Whatever. Okay, so in the earlier case, I mean, in this case, you had shown that this is equal to this Jacobian is equal to 0. This is a not a linearly dependent, but it is a non-linearly dependent system, equation system. Y2 is the square of y1. So in this case, if you have any type of dependence, then the Jacobian will become equal to 0. Okay, so we can generalize this to, or we can, this is a general result. So if you have two equations or more than two equations and they are dependent in some way, then the resultant Jacobian determinant will always be equal to 0. So instead of square, if you had taken cube, we would still have it, the Jacobian equal to 0. In this case, for instance, we have got three equations. If we had looked at the Jacobian, it would still be 0. Okay. Now, in the case of a linear function, let us suppose that we have a linear equation system like this: a11x1 plus a12x2 equal to d1. D1 is a constant. So we have n equations and we have got n variable. Now let us define these coefficients as the first order partial derivatives, del yi by del xj. So that means a11, these coefficients are the derivative of y1 with respect to x1, y1 with respect to x2, and so on. This is the derivative of y2, y2 with respect to x1, y2 with respect to x2, and so on. So the determinant which we form by the coefficients is equal to the Jacobian. I've not written it over here, but it will be okay. So if this equation system is dependent, then the Jacobian or this matrix, A matrix, will be equal to 0. Now, so far we have dealt with n equations and n variables. Okay, so that means, I mean, we are dealing with the number of rows is equal to number of columns. Okay, as in a determinant. But it is also possible to have some extra variables. Well, again, this is an error over here. I should write matrix. So we can have 3 equations, but 5 variables. So in that case, the matrix will be like this. Three, 4, 5. So this will be y2 by del x1, y2 by del x5. This will be y3 by del x1 to y3 by del x5. Okay, so what we can do is, in this case, we can take 2 of the variables to be constants. They can be any variable. You can take x2 and x4 You can take x1 and x5. For convenience, we are simply taking x4 and x5. Now you have this is a 3 into 3 matrix. Okay, and we can take the determinant. Okay, so if we have extra variables, more variables than their equations, we can obtain a Jacobian determinant simply by assuming that the extra variables are constant. Some of the extra we take the extra variables. Suppose there are 2 extra variables, there are 3 extra variables. These variables are constant. So in that case, the question of taking partials will not arise. These partials will all be equal to 0. Okay, is it clear? Okay. Now we return to the constant elasticity of substitution production function. This production function, as we have said, can be written in this form. If you want, you can take this minus rho common, whatever, it doesn't matter. Anyway, now we have some restrictions on the parameters. We have 3 parameters over here, A, del, and rho. E can be interpreted as the efficiency parameter. It indicates the technology. So the higher the value of A, that means given the value of labor and capital, output will be higher. We are using a more advanced technology. If we want to compare with the Cobb-Douglas production function, then remember the Cobb-Douglas production function is Q equal to A, L to the power of alpha, K to the power of 1 minus alpha. So in that case, the A's in the CS production function and the A in the Cobb-Douglas production function are both equivalent. Both relate to the technology or the efficiency of the production function. What is del? The equivalent of del in the Cobb-Douglas production function is alpha. It indicates what we call the distribution parameter. What is the relative share of labor in output? What is the relative share of capital in the output? Okay. And finally, rho. Rho is something which does not have a counterpart in the Cobb-Douglas production function. Rho is the substitution parameter. It indicates the elasticity of substitution. And if you remember, the elasticity of substitution is simply elasticity of substitution is sigma equal to relative change in the capital labor ratio, input ratio by relative change in the price ratio. So in other words, when the input price ratio changes, how much does the input ratio change? So over here, I've written it in the K by L format. You can easily reverse this. You can also write this as a L by K format. But in that case, the input ratio must also be W by R. Okay. So the Cobb-Douglas production function has the following properties: that the CS production function is homogeneous of degree 1. I made a mistake, I wrote 0. So this Cobb-Douglas production function is homogeneous of degree 1, which implies that it is a constant returns to scale production function. Remember, returns to scale is you're increasing all the inputs by the same ratio. Output will also increase by the same ratio. So that is why homogeneity implies CRTS. The second and third property are almost similar. Isocones are negatively sloped and they are convex to the origin. Let's look at isocones. The fourth property is the constant elasticity of substitution CS production function is quasi-concave for positive values of labor and capital. The fifth property is that the value of sigma, elasticity of substitution, is 1 by 1 plus rho, and rho is a constant, so sigma will also be a constant. And the final property is that the Cobb-Douglas production function is a special case of the CS production function. Now, I want to discuss the proofs of these four properties. So I'm not going to do the convexity or the quasi-concaves because they require some additional information which is better covered in the next semester. Okay. So the first property is that the CS production function is homogeneous of degree 1 in labor and capital. So over here, I've written the production function. We increase labor and capital by lambda times. So instead of K, we put in lambda K. Instead of L, I'm putting in lambda L. So I can take out from over here, I can take out the value of lambda. So lambda minus rho. This will also be lambda minus rho over here. And over here, I'm taking out lambda to the power of minus rho is common. So this part is the same earlier production function, Q. So A into this part is Q. And lambda is, I've taken out lambda over here, lambda minus rho to the power of minus rho into 1 by rho. So this becomes just lambda. Okay. So Q1 is equal to lambda Q. So what is the power of lambda? It is 1. So that means by Euler's theorem, the CS production function is homogeneous of degree 1, linearly homogeneous. Okay. So will I move on to the next slide or do you want some time to copy it down?
So sometime. So
Yes.
so on the third step, so are we taking lambda common?
Which this is the third step?
Yes, sir.
Yeah, we are taking lambda common.
Yes, sir.
This lambda to the power of minus rho. It is here and here. Okay. Will I move to the next slide?
Yes, sir.
Okay. The second part is the property was that the isocones are negatively sloped. Okay. So remember that dk by dl is equal to minus mpl by mpk. This is the slope of the isocont. So we simply have to find out the marginal products and take the ratio. So this is the CS production function. I've written it for convenience. MPL is dq by dl. So A is common, is a constant. I put A over here. I have to take the differential of this entire thing. I treat this as Z. So minus 1 by rho will come over here, and there will be a minus 1 over here. Minus 1. Then I have to take the differential of the derivative of the bracket. K is a constant. So I have to differentiate L. 1 minus del is common. I keep it over here. So derivative of L minus rho is minus rho will come down and minus rho minus 1. Okay, so this minus 1 by rho and minus rho cancels out. Okay, so 1 minus del I've written over here A. I've just simplified the power over here. Okay, L to the power of minus, I've taken minus 1 common. Okay, so I've written this part. Okay, so I've written this and I have taken A of to the power of rho over here in the denominator. So that means A to the power of rho must also come in the numerator. I'm multiplying this term by A to the power of rho divided by A to the power of rho. So this will become A 1 plus rho, denominator 1 plus rho. Okay. Now if you look over here, just ignore the 1 plus rho over here. Look at this part. Ignore the 1 plus rho. Okay. So this is 1 brackets, this is minus 1 by rho. So this is basically Q to the power of 1 plus rho. L also okay. So this is Q 1 plus rho and L this is minus 1. So I can take down L 1 plus rho. So this becomes 1 minus del by divided by A to the power of rho. This is Q, this is L, and the entire thing is to the power of 1 plus rho. Okay, if you have any problem over here, I'll repeat this step. Or I'll work it out manually. Achha. Now, when we are taking the derivative of Q with respect to L, K, MPK, we are going to follow the same pattern. See, what is the difference between K and L? The only difference is in the coefficient. This was 1 minus del and this is del. So that means I'm going to get the same expression for this. The only difference will be instead of 1 minus del, I'm going to have del over here. So I've written MPK. I've not done the derivative, but you can do it if you want. MPK is equal to del and the remaining terms are the same. Okay, so dk by dl is equal to minus MPL by MPK. So I have written this 1 minus del A rho over here and MPK I've written in brown over here. Okay. So 1 minus del and del will remain. A rho will cancel out. The Q also cancels out. K will go to the top. KL. Okay. Since del lies between 0 and 1, 1 minus del is positive. Okay, so this is positive, this is positive, this is also positive. So that means dk by dl will be negative. The negative sign will remain. Okay, so the slopes are negatively sloped. The isochorns that we get are negatively sloped. Okay, I'm going to the next slide. Now, over here we are trying to derive the elasticity of substitution. So, not over here. Okay, over here. Okay. Now, the least cost combination, of labor and capital, that is the equilibrium of the firm, is given by this condition. The marginal rate of technical substitution is equal to R by W, input price ratio. In other words, ratio of marginal products is equal to input price ratio. Okay. Now, we have shown, derived from here, that MPL by MPK is equal to this term. Okay, there's a minus, this minus will get cancelled. So this is this term. Okay. So over here we are taking the reverse of this. There's a mistake over here. Let me see, I'll correct it. Oh, So this will be yeah. Okay. So in the earlier case, I had derived MPL by MPK. I'm just reversing this. So this will be MPK by MPL. I'm putting in the value of this MPL by MPK over here equal to R by W. Oh, I need not have done this for in this case. এইখানটা ঠিকই ছিল, এইখানেই জাস্ট ভুলটা ছিল। সরি, এইখানটায় ভুলটা ছিল। Yeah. Okay, so the value of sigma. So the least cost combination of labor and capital is MPK by MPL equal to R by W. Okay, MPK by MPL is, or MRTS is equal to 1 minus del by del into this product. Okay. So in the next step, what I'm doing, I'm sending this del term over here. It gets reversed. Then I'm taking the square root. So I get K by L is equal to 1 del into this. Now this is a constant term. So I simply replace this as C. So C is defined as del 1 by divided by 1 minus del to the power of 1 plus rho. Okay. So this is the equation that I want to use. K by L is equal to C to this. Okay. Now sigma is defined as the elasticity of substitution is that when there's a change in input ratio, how much does your input combination change? Okay, so mathematically relative change in input ratio K by L by relative change in input price ratio, that is R by W. Okay. So we write in this form, and if we just reorder, you can see that what we are getting is dKL divided by drW. Now this is the marginal function. Okay. In the denominator, we have K by L divided by R by W. This is the average function. I mean, if I write this in this way, what is the average? Average is K by L. This is the average. And what is the marginal? It is this is the marginal. So the elasticity of substitution can be written as the ratio of the marginal function divided by average function. Okay. Now, the average function can be written in this way. We have K by L equal to C, this term. I'm using this expression. Okay, so I simply divide this by R by the input price ratio, R by W. So I get the average over here, and over here it should be minus 1 power. The marginal function is K by L equal to, taking this dkl by this 1 by rho will come over here, come down, and this will be minus 1. Okay. So marginal by average, I'm simply writing the equations. This is 1, by the way. You can see that the C will cancel out. R by W, 1 plus rho minus 1. This is the same term in the numerator and denominator. This also cancels out. So I simply have sigma is equal to 1 by 1 plus sigma rho. Is it clear?
So,
Yes.
so could you explain from the marginal function equals to K by L?
This part.
Yes, sir. Yes, sir.
I'm simply, see, I've written down this expression, right? This
Yes,
is
sir.
clear. Okay.
Yes, sir.
Now treat this as one variable and this R by W as one term. Okay.
Yes, sir.
Okay. So dkl by drw.
Yes,
Okay,
sir.
that is what I've written over here. Acha,
Yes,
C
sir.
is a constant. So I've kept
Yes, sir.
C.
Yes, sir.
Acha, R by W to the power of 1 by 1 plus rho. Okay, so the power must come down and I must make it minus 1. Power minus 1.
Got it, sir. Got it, sir.
Okay. So if sigma is equal to 1 by 1 plus rho, then ignore this part for the moment, okay? Forget the restrictions on rho. See, rho can be lie between, we know that rho is greater than minus 1, okay? So if it lies between minus 1 and 0, okay, so I put it, let us say minus 2, minus 0.2, minus 0.5. I'm basically reducing the value of the denominator, 1 minus something. So therefore, sigma will be, the numerator will be greater than denominator and sigma is greater than 1. Elasticity of substitution is greater than 1. If rho equal to 0, I simply have 1 by 1. Oh, sorry, there's a mistake over here. And if rho is greater than 0, then the denominator is greater than numerator, and so sigma will be less than 1. Okay, so we can see that for a CS production function, depending on the value of the substitution parameter, sigma will be either greater than 1, equal to 1, or less than 1 for a particular function. It is going to be constant. Okay. Now, if rho is equal to 0, then we see that sigma is equal to 1. Okay. Now, the Cobb-Douglas production function also has a value of sigma equal to 1. So then the question arises that is it possible that the Cobb-Douglas production function is a special case of the constant elasticity of substitution production function, okay, when rho equal to 0. Now, what is the problem with rho equal to 0? See, I've written the Cobb-Douglas production function over here. Sorry, I've written the CS production function over here. What will happen if rho is equal to 0? Look over
So
here.
undefined. Undefined.
Yeah, 1 by rho, this is undefined. So I'm taking the power will be something which is not defined. Plus infinity or minus whatever infinity. So in this case, we cannot evaluate the CS production function, right? That is why when we had defined the Cobb-Douglas CS production function, see, we have written it -1, rho is greater than -1, it is not equal to 0. Okay. So in case of the rho equal to 0, we are seeing that Cobb-Douglas production function will be equal to the CS production function. The problem is CS function does not exist at this point, rho equal to 0. So at this point, we have to use another rule which is called L'Hopital's rule. So suppose we have a function fx, and this can be written in this form, mx divided by nx. We want to evaluate this when x tends to a. Okay, normally it's not a problem. We can just find out the limit. But suppose we have either of the two cases, both mx and nx tends to 0. In that case, what will happen? So when x tends to a, both mx and nx tends to 0. So we have 0 by 0, undefined, right? The other case is that mx and nx both tend to infinity. They can be both plus infinity, they can be both minus infinity, it can be plus infinity divided by minus infinity, or minus infinity divided by plus infinity, any of the 4 cases. But it is basically a situation when we have infinity by infinity as x tends to a. In this case also, the function fx is undefined. So L'Hopital showed that the limit in this case, x tends to a, mx by nx is equal to m prime x divided by n prime x. So if I take the derivative of these two functions, then I'm going to get and find out the limit for x tends to a, I'm going to get the same result. So this is the result that I'm going to use, but L'Hopital's rule can be generalized. So instead of first derivative, suppose we are taking the second derivative. So sorry, suppose m prime x by n prime x does not exist. So both of them tends to 0, let us say, or both of them tends to infinity. In that case, what do we do? In that case, we take the second derivative. So it will be m double prime x divided by n double prime x. That will also give me the same result. Okay, have you got this? Okay, now suppose y is equal to 1 minus x squared by 1 minus x. Now what will happen if x tends to 1? 1 minus x squared is 0, 1 minus x is also equal to 0. So both mx and nx tends to 0. Okay, So in that case, we take the derivative. It will be minus 2x by minus 1. And so the limit of m prime by n prime is equal to minus 2x by minus 1. It is equal to, you can say it is equal to 2x. And the limit of at x tends to 1 is 2. We just put in 1 instead of x, we get 2. So what is the problem in the second case? Y equal to 2x plus 5 divided by x plus 1. You have to show that this is equal to 2 when x tends to infinity.
So when we put the value of infinity in the equation, so we want, so
Yeah.
we will get infinity by infinity.
Plus infinity by plus infinity, right?
That's
So what is the derivative? M prime by n prime?
so 2 by 1.
So is equal to 2. So limit of x tends to 2 is simply 2. So let me give a third problem. What is this equal to?
0 by 0.
Okay. So by L'Hopital's rule,
2x minus
2x
1.
minus 1 by 1.
sorry, just one second. 2x minus 1
By
by
1.
1, which is equal to 2x minus 1. So this is, the limit is equal to
7.
Sorry, I should have written a limit over here. Okay. So do you want a break over here? Or let me ask you a question. Okay. See, there was a very famous lawyer. Okay, he was the world's greatest lawyer. And a young chap, and he uh, came to him and said that, look, I also want to be a lawyer. So please take me as your junior, as your assistant, and teach me law. So the lawyer said no, the expert said no, I've never done this. I've never taken a junior assistant. But he begged and said that, look, if you do it, I'll be your servant. I will do whatever you tell me. So after a lot of time, he agreed. He said, okay, I'll take you as my junior. You will have to do all my work for me. And you will also have to pay me a fee of 5 lakh rupees. But uh, he said, I don't have this 5 lakh rupees now. He said, no, that's okay. You have to pay me the 5 lakh rupees. See, if I teach you law, you are also going to be a very famous lawyer. So you can charge very high fees. And after you win your first case, you can return me the 5 lakh rupees. So the young person agreed and he started working. He came over to the expert lawyer's house. He worked as a servant from day to night, and the lawyer also taught him all that he knew about law. After 3-4 years, he said that, look, whatever I know, I've taught you. Now you're my equal in law. So you can leave me and you can start practicing on your own. But remember that once you win your first case, you have to pay me 5 lakh rupees. So the fellow went off and the lawyer waited for his 5 lakh rupees. But unfortunately, what the person did was he did not start practicing. So he just sat idly doing some other work, but not fighting a legal case. So the lawyer realized after 3-4 months that, look, this chap is very clever. He's not going to pay me my 5 lakh rupees. So he got very annoyed and he told his friend that, look, he has cheated me. I should not have taken him as my assistant. Then one day he came back and told his friends that, look, now I've cooked his goose. So they asked how. He said, look, I've filed a case against him that he has not returned my 5 lakh rupees, and I filed a case that he should return my amount. He said, how will that help? He said, look, if I win the case, the judge will tell him that, okay, you have to pay your teacher the 5 lakh rupees. And if I lose, then according to the terms of our agreement, he has won his first case and therefore he will have to pay me my 5 lakh rupees. Understood this?
Yes, sir.
Achha. So most of you know this term. বরের ঘরে মাসি কোণের ঘরে পিসি. Durjay, have you heard this phrase?
No, sir.
It means that there are some people who are friends to both sides and they will just go and tell stories to the others so that A and B are always enemies. So there were some people who were the common friends and immediately they rushed off to the young chap and told him that, look, your teacher has filed a case against you and he's saying that whatever happens to the case, you have to pay him back 5 lakh rupees. So the chap laughed and he said, no, he's got it wrong. See, if I lose the case, according to the terms of the agreement, I've lost the case, so I don't have to pay him the money. And if I win the case, then that means the judge will tell me that I don't have to pay the money. So that means whatever happens, I will never have to pay the 5 lakh rupees to him, to my teacher. Okay.
Yes, sir.
So what do you think will happen now?
Sir, it is a bit confusing.
How? This is called uncommon common sense.
Acha, uncommon common sense. Acha, sir.
Yes. When we were in class 7, our teacher, the teacher who was supposed to teach us, was absent. He had taken a holiday or he was ill or something like that. And another teacher, and we were making a lot of noise. So another teacher came and invigilated. And he was not a regular teacher and he told us this story along with other stories. So you can see there's a paradox. Whatever happens, depending on the way in which you look at it, from the point of view of the teacher, whatever happens, he's always going to get the 5 lakh rupees. But from the point of view of the student, whatever happens to the case, he will never have to pay the 5 lakh rupees.
So basically, sir, from it depends really upon the point of view, what is really true and what is really false, right, sir?
No, but what is true?
That's what the thing is. Like both are thinking themselves to be true. That's why.
Yes.
Sir, Rosemary is asking you to admit her. She is letting.
Okay, but Rosemean.
Yeah, she texted me that. Details.
Acha. But she has to again try to enter. Otherwise, I can't allow her.
Sir, I wrote that to her.
দেখি কি করে. So, Bidusha, how cold is it?
Sir, Vidusha isn't in the meeting.
Oh, she's left.
Yeah. Tamang is
Okay.
there, sir. You can ask him. It's snowing, I
Yes.
guess.
Tamang, is it snowing?
No, sir. So like not in my place.
But I think it snowed in Ghum yesterday or day before yesterday.
Yes, sir. So it snows it like all in Tiger Hill and all.
Hmm. But in Darjeeling, it's not snowing.
Yes, sir. The main town is not snowing.
Yeah, now she's entering. Okay. Okay, give me 2 minutes. I have to clean my glasses. Then I'll come back. I'm muting myself. Okay. Okay, so let us try to show that.
Sir, I had a small doubt regarding the dates because today MD ma'am said that there will be Vivas. So will the Vivas take place after 18th Feb or before 18th Feb? Because I had some family occasion, so it would be better if I could know it.
Okay, give me. I'll tell you what the dates are. Uh, you are UG same. So 10th February you have, I think you're scheduled to have G, and
G is 16th Feb, I think. That's what you
16th
have
G
Feb.
told.
Yes, sir. For
is
math,
16,
16.
AECC is 17.
17th.
G is actually, sorry, this is RG. So what we are taking. So I don't know
Oh,
about
economics.
your G. Yeah. So it's not, this part is not relevant to you. You can see R starts from 21 to 28. This is the major. 21, 22, 23, then 25 to 28.
Sir, this is written and Viva both or only Viva?
This part is Viva. So 21st, you are going to have the written followed by Viva. The next 3 days. That half and next 2 halves. And 25th again, you are going to have my paper and then 26, 28. This is what we have scheduled. When is your family occasion?
25th.
কি আছে ওই দিন?
Sir, actually, it's my Pishi's marriage. So that week. It had been planned for a year, and now I thought the Vivas will take place before 18th Feb and the returns will take place around 21 and 22. But the Vivas will take place after. So I'm thinking what to do.
The Viva is not important. More important is the written.
The Vivas are very important and they are
Yeah, it has
tougher.
a lot of marks, but see, your Viva I can shift easily to 26th or 28th. That's not a problem. But written we
Sir,
can't
then,
shift.
okay, sir. Okay, sir, I will see.
Written we can't shift.
And even the written
So,
is from 2 p.m. It's not even
No,
in the
the written
morning.
dates are good.
No,
The
written
written
is
dates
from
are
10.
fine.
It's from 10 to
21
12.
and no, written dates are fine. 21 and 22. Just thinking about the Viva date
21,
and also
22 কোথায় পেলে?
21 and
21.
25 it is.
This is the written part.
Okay.
I'm coloring it green. Okay. And this is the Viva. I'm coloring it in blue. So 21st, 10 to 12 is your written. 25th, 10 to 12 is your Viva. Is my written.
Okay, got it.
Mathematics.
Morning is no
so
problem. So Viva dates I will see.
Yes. Yes.
So what kind of questions will come like in the written thing? Like numericals?
Yeah. Numericals will come. Numericals may come. I can ask you some proofs.
So, sir, how much marks we will have Viva for this time?
30 marks, it is written. 30 marks.
And
Viva is
written
30, 40.
and written is 40.
Mhm.
30, 30, 40.
Sir, can you put this part in the classroom?
যেটা হবে যে তোমাদের আমাদের এখন তো পরীক্ষাগুলো চলছে, এরপরেই তোমাদের যে ফর্ম ফিল আপ হয়ে যাবে তারপরেই এটা ফর্মালি রিলিজড হবে, অ্যান্ড উইথ সাম অ্যাডিশনাল ডিটেল আপলোডিং ওইসব টাইম দিয়ে। So till it is released, I can't. I mean, I can informally let you know, but I can't formally tell you what are the dates.
স্যার ফর্ম ফিল আপটা কবে থেকে হবে?
ফর্ম ফিল আপে তোমরা নোটিশ পাওনি?
Feb
No.
1, Feb 1.
Sir, we have to pay the fees by 30 and then after that is the form fill up.
From
Yeah,
1 Feb to 10 Feb is form fill up.
Yeah, I haven't seen the notice. Let me see. Let me see. Examinations. Yeah, UG and PG. These are the important dates. So online payment is 14th to 30th. And then from 1st to 10th is the form fill up. So now, if you have any problem with filling up the form, okay, please, I mean, after you have paid the form, paid the fees, please keep a record of the online transaction. Okay, first, so if there's any problem, then you can submit these documents by 1st and 4th. Okay, and you'll be, I mean, we will take some steps. So once you have paid the fees and you get the acknowledgement, please download it and save it. Okay. And please remember that 30th January is the last date. If you don't pay the fees, you will not be allowed to sit for the exams. Okay.
So that means you can adjust the Viva dates a bit, right? Okay. Like
No,
if I want, I can.
we can't change the Viva dates as
No,
such.
not the dates. With the 3 dates, I can choose any one date. If like
No,
if there is problem.
it's not a case of anyone can choose any date. You'll have to give proper documentation.
So what kind of documentation?
পিসি বিয়ের কার্ডটা পাঠিয়ে দিও স্ক্যান করে,
Okay, sir, sure.
তাহলে আমার সুবিধাও হবে, বা আমাকে আমাদের সবাইকে ইনফ্যাক্ট নেমন্তন্ন করতে পারো। ডোন্ট
হ্যাঁ
ইউ থিংক
স্যার,
দ্যাটস আ
ভালো
গুড
idea তো।
আইডিয়া?
হ্যাঁ স্যার, ভালো
হ্যাঁ,
Yes, sir,
idea।
আমি
I can call
তোকে
you
আমরা
guys.
কোঅপারেট করব, তোকে হেল্প করব
হ্যাঁ হ্যাঁ,
আমরা।
যাবো
Oh,
যাবো
surely.
যাবো স্যার।
রাখিস।
Oh, surely, surely. For Adrijit, it would be very close. He is in Chuchar, I think, Srirampur.
ও হ্যাঁ হ্যাঁ, চলে যাবো আমি।
So the matter is solved trivially. Pema Dorjai will face some problem, but at least he can come down for one day. I'm sure that someone will put him up. Okay, so this is the CS production function. Now, you can see that you only have a numerator, there's no denominator. Okay, so what we can do is we can divide this by A. In that case, we get okay, and then we take log. So if I take log, this will come over here. This is, in fact, I'm taking a natural log, so I should write ln. So now this is in the both the numerator and denominator has are functions of rho. Okay. Now if as rho tends to 0, then this entire thing will become 1. So the numerator this is -1. And the denominator is also equal to 1. So it's in a 0,0 format, it's undefined, and we can use the L'Hopital's rule is applicable in this case. So we have to find out m prime and n prime. See, n prime is easy. N prime is -1. So we have to find out m prime.
So 1 by
Yeah, no.
chain rule 1 by alpha delta k to the power minus rho plus 1 minus
Sorry, this is a mistake.
minus rho delta k.
Wait a minute. Wait a minute. Let me see. So then I have to take the differential of this.
So minus delta k to the power minus rho
No.
ln k.
Okay. So limit m prime. Okay. So rho tends to 0. Okay, so if I put minus 0 over here, all this will become del 1 minus del. আচ্ছা এইখানে হয়ে যাচ্ছে তোমার মাইনাস, এটা তোমার 0 হয়ে গেল। সো আই হ্যাভ So I'm taking out the minus and making it plus. So this becomes 1. Okay. So limit of QA, this is rho 10 to 0 is equal to log of, let us say, K del L 1 minus 10, or limit, sorry এখানে লিমিটটা আসবে, this is equal to E আচ্ছা। So if we then take the exponential, we can keep it over here.
ln q by a. So how is it ln q by a?
No, sorry. এইটে না, এইটে লেখা দরকার নেই। এইটা হলো, so if we take the exponential, this will become QA. Yes, sorry. What were you saying, Bondini?
Sir, I was saying that that would be limit delta tends to 0 ln of q by a, because we have taken ln q by a equal to n rho by n rho. So,
You're saying this should be delta, not rho.
no, sir, I'm saying that limit delta tends to 0, then there would be an ln q by a, because we have taken ln q by a equal to m of rho by n of rho.
না, তুমি কোন পয়েন্ট, কোন লাইনটাতে বলছো সেটা?
This is the second last line.
This line?
Yes, sir. So that
Yes,
should
sir,
be
that one.
Oh, yeah.
Delta.
I've written del. এইটাই তো? Yeah, thank you for pointing it out.
No, sir, I was telling that that one would be limit delta tends to 0 log of q by a, because we have taken log of q by a equals to m of rho by n of rho, and not q by a equals to m of rho by n of rho. That initial function that we are taking.
Now, you're talking about this line?
Yes, sir.
Yes.
Then why is it being just q by a? We have taken it to be ln of q by a equals to the 0 by 0 form.
No, but we have taken হ্যাঁ, sorry, হ্যাঁ, this should be log over here. এটাই বলছো তো?
Yes, sir. Yes.
হ্যাঁ, sorry. আমি আসলে এখানে m প্রাইম ছিল তো, তাই ওইভাবে লিখে দিয়েছিলাম। Okay, you have finished this. Hmm. Okay, now I have covered this once, but I want to cover this again because sometimes you may have problems over here. Uh, See, suppose we have a indifference function. Instead of y, you can assume it to be equal to 0. Or let's better still, let's change it. Use a different pen. So d u bar is equal to 0. This is equal to f1 dx1 plus f2 dx2. Or if you take dx2 by dx1, this is equal to f1 by f2. What I can say to be u1 by u2. And we know that marginal utility is always positive. So that means this is a negatively sloped function. Okay. So we have dx2 by dx1. This is the slope of the indifference curve. It is equal to minus f1 by f2. f1, f2 are the first derivatives, marginal utility. If we take the second derivative, we are going to get convexity. Convex or concave. Okay. Now remember that if you recall the derivation of the indifference curve, then our assumption, what is the assumption made by Higgs when he derived these indifference curves? He simply assumed that the marginal rate of substitution is falling as we move down the indifference curve. Remember, this is an assumption. So that means you cannot prove this. Assumptions cannot be proved. Okay, so as we are moving down like this, the marginal rate of substitution will fall. Okay. So this implies that indifferent curves will be convex to the origin. In fact, when we were deriving the indifference curves, I mean, when MD was deriving the indifference curve, then one of the axioms was that indifferent curves were convex. It's easy to show and prove that the indifference curve will be negatively sloped. But convexity is an assumption. Convexity diminishing MRS is an assumption which cannot be proved. Okay, now the point that we want to discuss over here is that we know that indifferent curves are convex to the origin. What is the relation between this convexity and the earlier utility or earlier the Marshallian approach to consumer behavior? See, Marshall had assumed that marginal utility was diminishing. Okay, so this means that U11 or U22 are negative. U1 and U2 are positive, marginal utility is positive, but as we increase consumption, this marginal utility is going to fall. Now here we want to see how it is related to the convexity of indifference curves. So we want to look at two things. Is it necessary? Necessary condition means that if you have convex indifference curves, then mu must be falling. The other is sufficiency. So what we are seeing over here is that we have diminishing diminishing marginal utility. This will automatically lead to convex indifference curves. Yes. Do you want to say anything?
No, sir.
Okay. Okay, so we want to see whether diminishing So we want to see whether diminishing marginal utility is a necessary condition, or it is a sufficient condition, or it is a necessary and sufficient condition. There are three possibilities. It is only necessary but not sufficient. 2, it is only sufficient but not necessary. 3, it is necessary and sufficient. What we are going to show is that it is neither necessary nor sufficient. Okay. So these are not true. Okay. Now, before coming to the proof, let me just look at the problem intuitively. I start from a point A and I'm reducing this. Okay. Now remember that slope is del y by del x. In this case, it is equal to marginal utility of 1 by marginal utility of 2. Okay. So let us suppose that we are moving from A to B. So what is happening as a result? We are increasing the consumption of X1 and we are reducing the consumption of X2, right? X2 is falling, X1 is rising, right? Now, if the law of diminishing marginal utility holds, what will happen in this case? If X1 goes up, what will happen to marginal utility? Will it rise or will it fall?
Sir, it will fall.
This is MU1. And what will happen to MU2? X2 has fallen.
So then it
Rise.
should rise.
It should rise. See, according to Marshall, the marginal utility curve is like this. This is the marginal utility schedule. It can be a straight line, it can be convex, concave, whatever. It can be wavy, whatever. So in this case, let us look at the slope. MU1, this has fallen. MU2, this has increased. What will happen to the slope?
It will fall.
The slope will fall,
Yes, sir.
which implies convexity.
Yes, sir.
Okay, so we can see that if the law of diminishing marginal utility holds, then indifferent curves are convex. Sorry. Oh, someone is trying to come in. Enter. Okay, so apparently there seems to be a relation between diminishing marginal utility and indifference, the convexity of indifference curves. Right. In fact, this would imply that diminishing marginal utility is a sufficient condition for convex indifference curve. So law of diminishing marginal utility is a sufficient condition for convex indifference curves. But in reality, as I'll show you, this is not true. Okay, is this part clear to everyone?
Yes, sir. It is
Yeah.
clear.
Sir,
Yes.
so you have taught this part earlier also, right?
Yeah, but was it clear to all of you?
Yes, sir.
The
So
derivation?
for me, it is clear. So I don't know about others.
Yeah. What about the others?
Sir, I understood.
ঠিক আছে, তাহলে কোনো প্রবলেম মানে ম্যাথমেটিক্যাল পার্টটা is the mathematical part clear to everyone?
Yes, sir.
I mean this part. I mean how we are putting in the different values of f1, f2 over here. Is this part clear to everyone? Okay, anyway, in that case, I'll move to the final part. I think you have discussed substitution effect and income effect, right?
Yes, sir.
Yes.
Yes, sir.
Okay. So, if the price changes, the impact on consumption can be split up into two effects: substitution effect and the income effect. For a normal commodity, both the substitution effect and income effect are negative, so that the price effect is also negative. Okay. Okay, just 1 second, please. Sorry. So, actually, the proof of this, if you look at the substitution effect, the substitution effect, the own price substitution effect is always negative. Okay, so that means if PI changes, then the change in Xi due to the substitution effect, this will always be negative. If PI increases, Xi will fall. If PI falls, Xi will increase. So the substitution effect is always negative. Now, if you are looking at cross price effects, so PI changes and you want to look at what happens to Xj. I not equal to J. Okay, so in this case, we have you can have substitutes or you can have complements. In case of substitutes, if PI increases, Xj will also go up. So what is the substitution effect? It is always positive. In case of complements, if PI goes up, Xj will fall. So the substitution effect is negative. Okay, is it clear, everyone? If it is an own price effect, the substitution effect is always positive, negative. If it is a cross substitution effect, then it depends upon whether the two commodities are substitutes or complements. So the proof I'm going to cover partly when I complete the next module. Now, when we come to the income effect, when income goes up, what happens to Xi? If it is a normal commodity,
Increase.
So increase.
so this is for a normal commodity. And if income goes up, Xi falls, we call it an inferior commodity. Okay. Now, if you look at the price effect, the actual derivation is something like this. Okay. So if you look at the slope part, del xi by del m, I'm talking about normal goods. This is positive, right? But you have a negative sign in front. So what is this? This will be negative. Okay. And this is what we call the income effect. So in case of a normal good, the income effect is negative. In case of a inferior good, income effect is positive. Okay, why I'm explaining this? That it may appear very surprising that M is going up, X is going up, but we see that the income effect is negative. The reason is that the income effect, the derivation of the income effect is minus xi into del xi by del m. What we have shown over here, this part, what I've shown over here, this part, m and x, relates to del xi by del m. Okay. But the income effect is xi is positive, so that's not a problem. There's a minus sign in front. That is why we say that the income effect is negative. Is it clear why the income effect is negative?
Sir, I have doubt. I have two doubts, sir. Sir, the first thing that I would like to ask is,
Yes.
for the complements, why is the substitution effect less than 0? So that part I
Negative.
yeah. Why it's negative? So that part.
sugar and tea. These are complements.
Yes, sir.
Suppose the price of sugar goes up. Before the price increase, you were having 5 cups of tea every day. Now what will happen? The price of tea is same. But if you want your cup of tea, you will have to buy sugar. That has become costly. So what will you do? If the price of sugar goes up, your consumption of tea will also fall.
Yes, sir.
So that is why we say that it is negative.
Okay, sir. And the second thing is, sir, the on the right hand side of the page you have written, sir, delta xi delta pi is equal to that term, sir.
You bar. This one.
On the right hand side of the page, on the topmost corner of that part,
হ্যাঁ
sir.
এই জায়গাটা
হ্যাঁ হ্যাঁ ওই যে টার্মটা লিখেছেন that term, sir, on the
হ্যাঁ
yeah, this part on the right hand side,
হ্যাঁ
so
হ্যাঁ
that part I mean, sir, how it's coming, sir.
ও এটা এটা you I can't show you right now.
Oh, okay, sir. Okay,
Data
sir. Okay.
derivation.
Then it's okay.
You
Then
have to
it's okay.
take this as given. I'll show
Okay, sir.
this to you partly after I complete the next module.
Okay, sir. That's okay.
Even
That
then I won't be able to do the proof.
acha, acha, it's okay, sir. It's okay.
আচ্ছা। আচ্ছা, now if I look at an inferior commodity, what is the relation between del xi and del m? What is the sign of this? Look at this. When m goes up, x falls. তোমরা inferior good করেছো তো?
Yes, sir.
Yes, sir.
হ্যাঁ। So if m goes up, xi falls. So what is the sign?
Sir, negative.
Negative.
It is negative. But remember that the income effect is you have a negative sign in front. Okay, so this part is negative, this is positive, this is negative. So what will be the sign of the income effect? It will be positive.
Yes, sir.
Okay. So remember, the income effect is not the relation between m and x. Income effect is not del x by del m. It is minus xi into del xi by del m. Okay, the minus sign is there. That is why, see, this is a direct relation. What do we call such relations? Positive. Right? But we are seeing that the income effect is negative. Here we can see that if m goes up, x falls, but we say that income effect is positive. This is because of this negative sign over here. Okay, is it clear to everyone?
Yes, sir.
Okay, so I'll finish this a bit quickly because it's not much to do. Okay, now we can have the following cases. Suppose we are looking at a normal commodity. Okay, so the price effect is equal to substitution effect plus income effect. Now, what is the sign of the substitution effect?
Negative.
Yes? What did you say?
Negative, sir. Negative.
Negative. And income effect?
Negative.
So therefore, the price effect is always negative. Okay. আচ্ছা। what will be the value of the price elasticity? I just want to know the sign. Can it be,
Negative.
remember price elasticity is equal to this is price elasticity and income elasticity is equal to, sorry, there is no, yeah. So what is price elasticity? It will be negative. And what is income elasticity? For a normal good,
Positive,
yes,
sir.
this will be positive.
Sir, how is the price elasticity being negative? There is a minus sign before
হ্যাঁ,
the
অ্যাকচুয়ালি যেটা, হ্যাঁ সরি, আমার এখানে মাইনাস সাইনটাকে এটাকে আমরা লিখছি, এটা আমি ভেবেছিলাম করবো, তুমি করবে। এখানে যেটা হচ্ছে ডিএক্স ডিপি, বিকজ ডিএক্স ডিপি ইজ নেগেটিভ, দ্যাট ইজ ওয়াই উই পুট ইন আ মাইনাস সাইন।
Yes, sir.
ওকে, আচ্ছা, নাও লেট আস লুক এট দ্য inferior good. Okay, so the price effect is equal to substitution effect plus income effect. What is the price substitution? What is the substitution effect?
Negative.
It is always negative. What is the income effect?
Positive.
Positive.
Now, what will be the sign of the price effect?
Negative.
Why?
So negative plus negative into positive is negative.
Negative, there's no into, this is a plus.
Oh, yes, sir.
Okay, so now
Sir,
you
it
have,
can be negative.
So it
positive,
depends
or
on the
zero.
value of income
It
effect and
depends on the
substitution
sign.
effect.
yes. Okay, so if the income effect is greater, sorry, if the, let us suppose the substitution effect is greater than the income effect. In that case, what will be the price effect? So this is greater.
Negative.
What will be the price elasticity? It will still be negative. Okay, because when your price is going up, demand is falling. What will happen to the income elasticity?
Negative.
Negative.
Yeah. Okay. Now, it is quite possible that your income effect can also be greater than substitution effect. In that case, what is your price effect? It
Positive.
becomes positive. What is your price elasticity?
Negative.
Why?
No, sir, positive. Because price effect is positive.
And income elasticity?
Negative.
Okay. Now, this case is called Giffin's good. So this is a, I've written God, but it's not so grand. So Giffen's good is a special type of inferior commodities. Okay. When the positive income effect is greater than the negative substitution effect, so that the price effect becomes positive. So in that case, what will happen is, if you look at the demand curve, what will be the demand curve like? It will be positively sloped. What will be the slope of the of an inferior commodity which is not a Giffen's good?
Negative.
Negative.
It is still, sorry. So this is negative. Similarly, a normal commodity will also have a negative slope. So now if we look at now if I look at this income demand curve. What is the income demand curve for a normal commodity?
Positively sloped.
It is positively sloped. For a inferior commodity,
Negatively sloped.
for an inferior commodity, it is negatively sloped. For a Giffen's commodity also, it is going to be like this. Okay, so you have to be a bit careful about this. But try to remember that or keep in mind that an indifference, a Giffen's good is also an inferior commodity. Okay. Giffen's
Yes,
good
sir.
is a special case of a inferior good. So if I'm saying that it's a Giffen's good, is it inferior? You have to say yes, it is also an inferior commodity. Remember that. Okay. And okay. Okay, now I want to end with one final, a very small proof, but which is very important. See, remember that the demand function is, this is the demand function. Own price cross price, and income. And remember that a demand function is homogeneous of degree 0 in prices and income. Okay. Now, if you use the Euler's theorem, we have n into xi. This is equal to pi del xi by pi pj del x. Sorry, this will be del I. There's no xg over here. This is pj plus m del xi by del m. Okay. Now, what is the value of n? N is 0. So, n into x, this is equal to 0. Okay. Let me write down the first part. This is equal to P1 X1 plus P2 X2. They are just two commodities. Actually, this should be 1 in that case. Okay, so let me put it 1 over here. This is equal to 0. Or let us take the P1 common. So I have del X1 by del P1, and this is P1 common. So I have del X1 by del X1 by del M. Okay, this is, I am taking P2 common. This is actually P2. So in that case, it will be del X1 by del P. This is X2 by del X1 by del M equal to 0. Now remember the price effect as I've shown you. Okay, so the price effect was something like this. This is equal to own price substitution effect minus X1 this is equal to S12 minus X1. Okay. Now look at this. If I bring this income effect to the right hand side, del X1 by del P1, del X1 by del P1, this will become plus X1 del X1 by del M. So what is this term equal to? This is equal to S11.
S11.
Yeah. Sorry, this should be plus actually. I made a mistake over here. This is S12. Okay. Now, P1, P2 are always positive. What is S11? Own price substitution effect is always negative. So what will be S12? This is negative. So this has to be positive, otherwise it can't be 0. So what will be the sign of S12?
Positive.
This is positive. So if the substitution effect is positive, what does it imply? Substitute or complement?
Substitute.
So if you have two commodities in a two commodity world, can the commodities be complements? If they are complements, then S12 becomes negative. So you have negative plus negative. Can it be equal to 0? No. So in a two commodity world, the commodities must be
Substitutes.
they have to be substitutes. Okay. Now suppose we take an n commodity world. So that means x1 is a function of p1, p2 up till pn and m. So it is homogeneous, so it will be p1 del x1 by p1, p2, by the same logic. Sorry, this will not be x2, this will be again x1. Pn del x1 by del p1, this will be m del x1 by del m equal to 0. So by Euler's theorem, we have this result. Now, if you substitute in place of m, and you are going to get terms like this. This will be okay. This is S11, this is S12, and so on. P1 S1n equal to 0. Okay, now this is negative. Okay, now S12 can be either positive or negative, right? But is it possible for all these commodities to be negative? So S12
No, sir.
to S1n. This is not possible. At least one Sij has to be positive, right? Now Sij positive implies S1J positive implies substitute. So out of these n commodities, at least one good is a substitute. You can also restate this in this way. All goods cannot be complements. Okay. Got this? Okay, so I have ended the multiple variable functions. So you should know what the optimization in this case is, but that MD is going to cover in the next semester with constraints or without constraints. In this semester, I'm going to turn to the last topic, which is matrices and determinants. Okay.
Yes, sir.
So I'm closing the presentation.